Dear students, in this video we are going. So again, here we will take our start with the de Broglie wave. De Broglie wave, as this is the wave which is associated with the material body. Associated with material body. So the amplitude of this wave is of the de Broglie wave or correspond to the finding that correspond to the moving body. It reflects the probability of body being there at particular time and at particular space. However, we cannot represent uh, um, it de Broglie wave by a general wave formula. Here the general wave formula can be written as like y is equals to a cos of omega t minus kx, as this is our general wave formula, but we cannot represent the de Broglie wave by this formula, as this formula describes an indefinite series of the wave all with the same amplitude a. So what we will do instead of using this formula? So instead of using this formula, the wave associated with the moving body can be represented by a wave packet. Can be represented by wave packet. So now what is the wave packet? We can say that it is a group of waves, different waves grouped together, or we can add a different waves that combine to form a wave packet. So this is the group of the wave whose individual waves has amplitude such that the probability is localized within the certain region of space. So there are different reasons for using a wave packet instead of wave equation for the de Broglie wave, which is associated with the moving body. One of the reasons for using the wave packet is that as the wave, which can be represented by psi wave function psi, and this wave function, which is our psi, which is associated with the moving body, is spread all over the space. It's spread all over the space. So it is difficult to localize a body within the certain region, or to localize a moving body as the wave associated with the body is spread all over the space. But when we consider a wave packet as wave packet, we said that it is a combination of different wave. Their amplitude is adjusted so that this is their, for example, if this is their resultant. So the resultant wave of the wave packet uh, is so that their amplitude of the individual wave within this wave packet is so adjusted that individual wave interfere constructively within the certain region. So they interfere constructively within the certain region where the probability is the maximum for the body being there, and destructively in the other region, so making a minimum probability in the other region. So wave packet associated with the particle is well localized. So second reason for choosing the wave packet is that wave packet is well localized. Is well localized, and being well localized, so we can easily identify, we can specify the particle within the certain region of the space. Now we come to describe an example of the wave. The familiar example of the wave packet group of the wave is the beat. Okay, beats. The beats produce here, for example, if we have two sound waves, if we have two sound waves and of the same amplitude but slightly of different frequencies, that is two sound wave of same amplitude of both the wave is the same but slightly different frequency, slightly different frequencies. So when both the sources produce a sound simultaneously, the sound we hear has a frequency equals to the average of two original frequency. So resultant frequency is the average of two original frequencies. That is the frequency which we hear when two sources produce a sound simultaneously, and its amplitude rise and fall periodically. So how amplitude rise and fall periodically? The amplitude, that fluctuation occurs as many times per second as a difference between the original frequency. That is how many beats we can hear, that is how many rise and fall of the frequency which we can hear, that are called as amplitude fluctuation. Amplitude fluctuation. So the fluctuation produced as many time per second is equals to the difference in original frequency. Difference in original frequencies. Okay, for example, if the original sound waves have a frequency of 440 and 442 Hz, we will hear a frequency of sound of 441 Hz, which with the two loudness peak, which is called as beats per second. That is, if one source has a frequency of 440 Hz and other one has the 442 Hz, then the sound which we will hear will be of frequency 441 Hz. That is, it will be consist of two loudness peaks. Two loudness peaks. That is, there will be two beats per second, which will be heard by these two sound sources of the same amplitude and slightly different frequency. Okay, now we will explain a mathematical way to describe a wave group. Mathematical way to describe a wave group. Wave group. So how we can describe it mathematically? In terms of superposition of individual waves of different wavelength whose interference with one another in the variation of amplitude with with a definite form which form a definite shape of the group of the wave. Let's suppose we have individual wave like this one of this wavelength, and then another one like this one, and let's suppose still we have another wave like this one, another wave of amplitude like this one. So the individual wavelength whose interference with one another is such that with one another is in the results in the variation of amplitude which define the shape of the resultant, which is resultant wave of all these superposed waves. So this resultant wave is the group of the wave. So this shape is called as a group of the wave. So it is composed of number of individual wave of you can say their amplitude is so adjusted that they interfere in such a way they form a definite shape for the group of wave. So if the velocity of individual waves are the same, that is if all individual waves, if all individual waves of same velocity, of same velocity vp, that is of same phase velocity, then the group of wave will also move with the velocity with the phase velocity, that is their velocity of the group of waves then in this case will be the phase velocity. However, if the situation is different, for example, if phase velocity varies with the lambda, if phase velocity, which is the velocity of individual wave, varies with lambda, that is with the wavelength, then what will happen? This actually, when the phase velocity when varies with the lambda or wavelength, this effect is called as dispersion. We call this fact as a dispersion. So the dispersion of different individual waves do not proceed together. As a result, the wave group has a velocity different than the phase velocity. So the this velocity then in this case will be called as Vg, that is group velocity. Group velocity, that is when individual waves have, if the phase velocity varies with the lambda, then the resultant of these waves have the velocity Vg, which is called as group velocity. If all individual waves are of the same velocity, that is Vb, then group velocity will also be of the same like the phase velocity, that is it will also be the phase velocity. So the second case in which we say that if phase velocity varies with lambda, so this is the case with the de Broglie wave. So the waves associated with the moving body that are also uh, their phase velocity also varies with the wavelength. So their velocity is the group velocity, that not the phase velocity, because the different velocity of the different waves within the group varies with the lambda in the case of de Broglie wave. Now let us suppose the wave group arises from the combination of two different waves that have the same amplitude but differ in some angular frequency. So let's suppose we have two waves that combine to form a wave group, that combines to form a wave group. So such that these individual waves has um, individual wave are of the same, you can say that of the same amplitude, or of the same amplitude, but their frequency of these individual waves varies by an amount delta omega, and their wave number also varies by an amount of delta k. So let's suppose we have a wave which can be represented by wave 1, and its equation is a cos of omega t minus kx, and second wave which can be represented by y2 and is equals to a cos of omega plus delta omega, that is the change in the frequency, d minus k plus delta k, that is the small variation in the wave number, into x. So the resultant displacement at any position x is the sum of the y1 and y2. That is, we can write it like y is equals to y1 plus y2. So here we can use an identity as cos of alpha plus cos of beta, which can be equals to 2 cos of 1 by 2 into alpha plus beta into cos of 1 by 2 into alpha minus beta. And also we know that cos of minus theta is always equals to cos of theta. So using this identity we can find the combination of y is equals to y1 plus y2. So now we are going to add both equation by using this identity, and what we will get, it will be equals to is equal to y is equals to 2a cos of 2a cos of 1 by 2 into 2 omega plus delta omega into t minus 2k plus del k into x into cos of 1 by 2 delta omega t minus del kx. So again we can say that 2 omega plus del omega is approximately equals to 2 omega, because this del omega is very small, we can ignore this quantity. So 2 omega plus delta omega is approximately equals to 2 omega. And secondly, 2k plus del k is approximately equals to 2k, again because this change is very small. So by using this condition, so the y will be equals to 2a cos of omega t minus kx into cos of delta omega by 2 into t minus del k over 2 into x. So this is the equation which representing the beats. So what this wave equation tells us, this wave equation tells us that tells us that wave of angular frequency omega and wave number k has superimposed upon it a modulation of angular frequency delta omega by 2 and delta k over x. So from this we can find out the phase velocity and group velocity. So the phase velocity here, which can be represented by, that is the phase velocity of resultant or beads, phase velocity is equals to omega over k, and the group velocity, that is the velocity of the beads, that is the phase velocity is the velocity of individual wave, and group velocity, which can be represented by dg, is equals to del omega over del k, and we can write it like delta k omega over delta k. So these are the small changes. So depending on how the phase velocity varies with the wave number in any particular situation, the group velocity may be the less than or greater than the phase velocity of individual waves. If the phase velocities, for example, if phase velocity of all individual waves are the same, okay, if phase velocities, if all individual waves are same, then what will happen? So if the wave velocity of all individual waves are the same, then group velocity will be equals to the phase velocity, that is, it will be the same. And here the angular frequency and the wave number of the de Broglie wave associated with the body of mass m0. Let's suppose if we have a rest mass, m0, this was, here we were talking about the moving body. Let's suppose if it's the rest mass of moving body is this body is the m0 and its velocity is v, then we can write the omega, which is the angular frequency. We can write it 2 pi v, and it will be equals to 2 pi m c square over v. And if instead of m, if we use here the rest mass, then this omega will be equals to 2 pi m naught c square divided by h into 1 minus v square over c square. So in the same way, the k corresponding wave number, which is equals to 2 pi over lambda, and that is, we can write it 2 pi mv over h. So here again, if we use a rest mass, then k will be equals to 2 pi m naught v over, it will be equals to h into 1 minus v square over c square. But as here we know that the group velocity Vg is equals to d omega over dk, and we can write it as d omega over dv divided by dk over dv. So first we need to find out the value of d omega over dv, that is d omega divided by dv. It will be equals to 2 pi m naught v over h into 1 minus v square over c square into 3 by 2. In the same way, dk over dv, that is the differential of k with respect to v, it will be equals to 2 pi m naught over h into 1 minus v square over c square power 3 by 2. So by putting the value of d omega over dv and dk by dv into this one equation, so group velocity will be equals to, it will be equals to d omega 2 pi mv m naught v over h into 1 minus v square over c square power 3 by 2 divided by, it will be equals to 2 dk over d omega dv 2 pi m naught divided by h into 1 minus v square over c square 3 by 2. So from here we get what we will get. We will get that Vg, which is equals to d omega over dk. This will be equals to V. That is Vg will be equals to V. So this is an amazing equation. These are the amazing results. This tells us what this equation tells us. This equation tells us that de Broglie wave group, which is associated with the moving body, that is de Broglie wave group, which is associated with the material body travel with the same speed as that of the speed of body. So both have the same speed, but we in our previous lecture we come across an equation in which we said that the de Broglie phase velocity, which is equals to omega over k, is equals to c squared divided by v. So here I put an important question, that is it possible for a de Broglie wave, de Broglie wave to move with a speed greater than the speed of light? So this equation tells us that this one equation, that is the de Broglie phase velocity is greater than the speed of light. But when we look at the group velocity, that is the group of the wave which is associated with the de Broglie wave group of a moving body, is equals to move with the same speed as the speed of body. So this equation become meaningless. It has no meaning because it is not uh, of any importance at all that the wave move greater than the wave which is associated with the moving body move faster than the speed of light. So that's why we always associate a group of wave with the moving body instead of a single wave. So we here is the wave concept of wave packet, which is very important, which is the wave packet, which is the concept, we can also say a group of the wave or wave group. So instead of a single wave, a group of wave is associated with the matter wave, with the material body, and this de Broglie wave group move with the same speed as that of the body. So the speed of this wave group is much less than c. So the fact that the phase velocity of is greater than the speed of light for de Broglie wave does not violate the special relativity because the phase velocity can be greater than the speed of light, because we have already said that the wave associated with the de Broglie wave spread all over the space. So we, instead of a wave, we take a wave group. So individual wave interfere with each other and their amplitude is adjusted so that they interfere constructively within the certain region to, that's why we can have the maximum probability of body being there become the maximum and destructively outside that wave packet. So the concept of wave packet is very important to define a matter wave. So thanks for watching. For more videos, please subscribe our channel.